Now we're going to look at a different method of solving a system besides graphing and substitution. Graphing is great when they're both y equals mx plus b. Substitution is good when one of the equations has been solved for a variable. And elimination is nice when you have both the x and the y's on the same side of the equal sign, and they're all lined up nice like we have in this equation. So what you always want to do with elimination is see if it's the, quote, easy case. The easy case is when you look at the x's and they have the same coefficient, or you look at the y's and they have the same coefficient. And when I say the same, I'm not really thinking about sign right now, I'm thinking about the absolute value. So this is 3 and this is also 3. When it's something like that, then that's going to be a really nice situation. The whole goal of elimination is to eliminate a variable. So you want to see if right now, since they're the same, are they going to eliminate? I have 3x minus 3x, which would give me 0x. So yes, it's going to currently eliminate. If it didn't, then I would need to change all the signs in one equation, which we'll look at in a minute. So what I'm going to do is just add it straight up and down, and that gave me 0x, 7y, equals 42 minus 7, 35. And now I have a little one-step equation. So all of a sudden my equation got a lot more straightforward. So I got y equals 5. But as you'll remember from the substitution video, that's my y value, but I also need an x value. So I'm just going to choose an equation. You can just choose the first one, or you can choose, if we end up multiplying by something, choose the one we didn't multiply by. So I'm going to use the first equation. 3x plus 3 times 5 equals 42, and solve that equation. So 3x plus 15 equals 42. Subtract 15 from both sides. So 3x equals 27. And divide by 3. So x equals 9. So now I have an x and a y value. Looking at number 2, I always want to check its elimination because you have the x and y's on the same side and they're lined up. So let's look at the x's. What are the coefficients of both my x terms? 5. Great. So that means this is my straightforward way to do this problem. And currently, if I added them, I would get 10x. That's not great. That's not eliminating. So in order to get them to eliminate, I have to do the opposite of one equation. So I'm just going to choose to do the opposite of this bottom equation. So I'm going to change all the signs in one equation. So I'm going to go negative 5x, negative 3y, and that negative 55 is going to change to a positive. And now I add it vertically. So 5x minus 5x is 0x, y minus 3y is negative 2y, and negative 45 plus 55, it's easier to think of it as 55 minus 45, which is 10, and divide by negative 2, and we get y equals negative 5. But wait, there's more. We have to keep going and plug that in. Since I didn't bother the first equation, that's the equation I'm going to use. 5x plus negative 5 equals negative 45. So that's 5x minus 5 equals negative 45. Two-step equation. Add 5. And divide by 5. So x equals negative 8. Number 3. Look at this one. Something a little funky going on, because if I look at my x's, those are both 6, and my y's are both 7. So hopefully this is my straightforward problem. And right now, if I do 6x minus 6x, that would give me 0x. So those eliminate. I don't need to change any signs. But what happens when I do that with y? Negative 7y plus 7y is 0y equals negative 8 plus 8 is 0. Well, what's 0x plus 0y? That's just 0. Now, is it true that 0 equals 0? Yeah, that's a true statement. Other true statements would be things like 4 equals 4, or negative 3 equals negative 3. Those are true, and when you have something that's a true statement after your variables have disappeared, that means infinitely many solutions. Infinitely many solutions. Now we're going to skip around a little bit. Let's look at number 8. Okay, so let's look at the x's. Are the x's the same? Yep. So as soon as you see they're the same, don't make your life complicated. Are they going to cancel right now? If I just added these straight, I have 6x. My whole goal is to eliminate my x, so I don't want to just leave it how it is. I need to change some of the signs. Once again, it doesn't matter whether I do the top or bottom row, especially if you kind of pay attention to what these two equations look like. Something interesting will happen. So I'm going to change that to a negative 3x, a positive 3y, and a negative 15. And now we just add it straight up and down. So 3x minus 3x is 0x, negative 3y plus 3y is 0y, and 15 minus 15 is 0. So we end up at that same situation like before. And when it's a true statement, that means it's infinitely many solutions. All right. We're going to skip number 9. I'm sure you can try that one on your own. And flip to the back and look at number 10. So at first, number 10 doesn't look like I can do my little shortcut here because I have a 4 and a 6. But if I squeeze on over and look at the y's, I have negative 5y, negative 5y. So since those are the same, I'm just going to add it straight up and down. But right now, if I added, I would get negative 10y, which doesn't help me with my goal of eliminating. So that means I need to change all the signs in one equation. I'm just going to, once again, do the bottom. That's what I usually do. So negative, positive, positive. And now we add up and down. So 4x minus 6x is negative 2x. Negative 5y plus 5y is 0. Equals negative 9 plus 11 is 2. And last step, I can divide by negative 2. So x equals negative 1. Now that I've got that, I can substitute that negative 1 in for x into one of the equations. Doesn't matter which one, I just use the one that I didn't mess with. So I didn't mess with the first one. So I'm going to do 4 times my new x value of negative 1 minus 5y equals negative 9. So negative 4 minus 5y equals negative 9. Two-step, add 4. So negative 5y equals negative 5. And divide by negative 5 on both sides. So I get that y equals positive 1. And that's all we got.